So what is a discrete random variable? A random variable x that takes a specific separate value such as x1, x2 up to xn. That is called discrete random variable, right? And what is probability distribution function? It is the table in which those discrete random variables are taken in one row, and the probability of those specific random variable is taken in another row, right? So this is what it is. And when a probability distribution function is valid, probability distribution function is valid only if the each and every probability lies between 0 to 1, and sum of all these probability will give me 1. If any one is not true, right? If any one is not true, that means my probability distribution function is not valid, right? Suppose I have to check for fx is equal to x square by 4, and I have given for x is equal to 1, 2, 3 and 4. I have to check whether my probability distribution function will be valid or not. So as you can see, when I will make the table, right? When I will make the table, then I will be having x equal to 1, 2, 3, 4. And as you can see, fx is equal to x square by 4. So it will be 1 by 4, 4 by 4 and 9 by 4. This is greater than 1. So this is not a valid probability function, right? Now what is mean or expectation value? So mean is denoted by mu and expectation value is denoted by E capital X. What is this? This is weighted average of all values of random discrete variable weighted by their probability. So this is summation of xi f of xi, and this is my x1 probability of x1, and then that is f, and then x2 f of x2 up to xn f of xn, right? This is mu or capital E x, right? And then I have capital E, and if it is a square of random discrete variable, then this will be written as summation of xi square f of xi, and this will be written as x1 square f of x1 plus x2 square f of x2 up to xn square f of xn, right? And now what is my variance? So my variance is sigma square. This is called variance, and it tells how spread out the values of random discrete variable are around mean, right? How spread are values of random x variable around mean. This is what variance tells, and the formula is given by summation of xi minus mu square into f of xi, right? So now I will show you one thing. Let me erase this. right? I can write this as summation of xi square f of xi plus u square and then summation f of xi plus minus 2xi mu here and fxi and this summation, right? So this is what it will give me mean. This is minus 2u square. This will give me 1, so it is plus u square, and this will give me e of x square, right? So it will give me e of x square minus u square. So this is also formula for my variance. This is variance, and a standard variance is given by simple sigma, right? Now coming on the next topic, we have, suppose I have given a table like this, random variable x and fx, and for x equal to 0, 1, 2, 3, I have fx 1 by 8, 3 by 8, 3 by 8 and 1 by 8, right? So you can easily find the value of mean, expected mean, and then e of x square, and then variance and the standard variance. You can find using these formulas, right? Now suppose I want to solve this. Let me solve this question, right? So I am doing the question. Here also. So let me solve this question. I am going to attempt this one. So see clearly, right? I have my calculator here, and let me find the value of u first, right? So it will be summation of xi f of xi, which will be given as x1 f of x1, which will be given as 0 into 1 by 8, plus x2 f of x2 will be given as 1 into 3 by 8, plus x3 into f of x3 will be given as 2 into 3 by 8, and x4 into f of x4 will be given as 3 into 1 by 8, which will be given as 8 below, and 3 plus 6 plus 3, 3 plus 3, 6 plus 6, 12, which will be given as 4 into 2, 4 into 3 will be 3 by 2, right? And similarly, e of x square will be given as, similarly here all will be a square, so it will be 1 square, then it will be 2 square, and all those I will replace with square. So I will get this time in below 8, and this is 3 plus 4 into 3, that is 12 plus 3, 15, plus 9, that is 24. So this will be 3. This is also correct. Now variance, it will be given as e of x square minus u square. So it will be 9 minus 9 by 4, and this will be 36. So it will be 25 by 4. 25 by 4 will be 6 point, just a second, this is right, and 3. So let me check the formula once again. The formula is okay. So where it is getting wrong. Sorry, this is actually yes, actually this is 3 minus u square will be 9 by 4. This will be 12. So this will be 3 by 4, 0.75. And this is variance, and a standard variance will be root of 0.75, which will give me 0.87. So this is the correct answer, right? Now let's discuss about the other topic, that is, let me erase this, and yes, now we will discuss about probability in which it is going from. Let me erase this also. Yes, so suppose I have probability going from let me erase this once again. It is going from A and X and then B. So it is going like this. So I will write this as, suppose there are sum of probabilities for all x from A to B, right? So this will give me, suppose I have x1, x2, x3, right, at A and B. So this will be probability of x1 plus probability of x2 plus probability of x3. Similarly, if I am given probability x less than equal to A, it will give me sum of all first values up to A inclusive, and if this is not given, sum of all probabilities but not including A, and if it is given as only from A to B, so it will be simply here probability of x2, right? A and B will be excluded, right? x1, x3 will be excluded. Now suppose I have a fair coin, right? I have a fair coin tossed 10 times. So as it is tossed 10 times and fair coin can give head or tail, my sample space will be 2 to the power 10. This will be my sample space, right? And what it is asking, yes, getting the probability of getting any outcome is, right? And then for each, suppose I have I want to get number of heads, right? How many times I can get head? So I have tossed coin 10 times, I can get head 10 times, or I can get head only 1 time, or I can get head 0 times also. So my random variable will go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? This is my x, random variable x, and my probability will be what? This will be, I will choose out of that 10 times, I will choose, right, x number of times, right, x number of times I got head, and this all happened with a probability, right, that is 1 by 2 to the power 10, right, because getting this thing is 1 by sample space, complete sample space, right, and especially that thing I want from that 10 times. So this is combination of 10 and x for getting that particular variable, and this is for getting that out of that sample space, right? So this is actually this is favorable condition, and this is my sample space, right? So if my question is asking one probability of getting exact 6 heads, so it will be probability of x equal to 6 will be, here I will put a x, here I will put 6, so it will be 10 comma 6 by 2 to the power 10. And if question is asking at least 5 head, I want at least 5 head, so what I will do, I will go up to px greater than equal to 5. So what I will write, probability of x equal to 5 plus probability of x equal to 6 up to probability of x equal to 10, right? This is what I will write, right? So what I will write is c 10 comma 5 plus c 10 comma 6 up to c 10 comma 10, and all multiplied with 1 by 2 to the power 10, right? This will be my answer. And suppose my question is asking at most 7 head, right? At most 7 head. So it will be probability of x less than equal to 7. And the same thing I did for this, I will also do for this, right? And then, right, so this is, and if it asks strictly between 3 and 5, strictly between 3 and 5, so it will be probability of x from 3 to 5, not inclusive, right? So this you can also find, this will be probability of x equal to 4 because we have excluded 3 and 5, right? Now I am erasing this, right? And now cumulative distribution function, right? CDF. So what is CDF? So cumulative, right? I am erasing this. So cumulative distribution function in which, let's say I have fx. So what will fx give me? It will give me total probability accumulated up to x, right? Suppose for f of x1 I will have f of x1, but for f of x2 I will have f of x1 plus f of x2, and for f of xn I will have f of x1 plus f of x2 up to f of xn, right? Now suppose I have two values. For that, suppose for a and b I have a cumulative frequency, right? So the difference between the two will give me probability of from a to b. This is what will give me difference in two cumulative distribution function values will give me probability between two values, right? Now let's talk about binomial distribution, right? So what is binomial distribution? When to use this, suppose I have an experiment, right? And that experiment either will be successful and either it will be a failure, right? Any experiment. Now there are n trials, n times I perform my experiment, and each time I either succeed or I fail, right? And every trials are independent. Each trials are independent, right? So what is n is my number of trials, number of time I perform the experiment, right? P is probability of getting success and Q is probability of getting failure, right? And P plus Q will always be 1, right? Probability of becoming successful and probability of failing will always give me 1. Then fx will be defined as, that is probability of that random variable x will be my C n comma x, p to the power x and q to the power n minus x, where x is from 0, 1 to n, right? This is the formula, right? Now I am solving a question, so let us see. Right, I have a question. A coin is tossed 3 times. Find binomial probability distribution of getting x heads. Right. So probability of getting a head is 1 by 2, which is a success for me, and probability of getting a tail is also 1 by 2, which is a failure for me. And coin is tossed 3 times, so n will be 3, and so my fx will be, this will be c 3 comma x 1 by 2 to the power x and 1 by 2 to the power 3 minus x. Now what I have to find, for exact 2 heads the probability will be, random variable x will be 2, and here I will replace 2, so this will be c 3 comma 2 1 by 2 to the power 2 1 by 2 to the power 1, right? This is, and then at least one head will be, right? This will be probability of x greater than equal to 1, so it will be basically probability of x is greater than equal to 1 will be 1 minus probability of x equal to 0, right? Because getting no heads, right? This thing I will remove from my total sum of all values, that will all probabilities, which will give me 1, right? And for strictly between 1 and 3, it will be x from 1 and 3, so it is asking getting 2 head, right? So this will be my answer, and this I will find. How this I will find? I will put 0 here, here, and I will write that, right? So this will be power 0 and 1 by 2 to the power 3. This thing will write, right? Now next question is I am erasing this. Next question is, a basketball player success rate of that basketball player is 80%, right? Because it is given in question, a basketball player makes 80% of free throws, right? So his success rate is 80%. So probability of getting successful is here 0.8, and probability of getting failure here is 0.2, and it is asked in next 8 trials find probability of getting exact 8 successes, right? So n is equal to 8 here, because 8 times he will throw the ball, right? So this will be combination of 8, right? 8 and p to the power, what was it? P to the power, yes, 8, and 0.2 to the power 8 minus 0, right? So this will be the answer, right? 8 minus 8 actually, because here it is n minus x. Now for at least 2 success. So at least 2 success means p of x greater than equal to 2, right? So either I will find p of x equal to 2 plus p of x equal to 3 up to p of x equal to 8. I can also find 1 minus p of x equal to 0 plus p of x equal to 1. This I can also do, right? Because the summation will give me 1, and here I will insert the value. So for x, this is 8 comma x, p to the power x and q to the power n minus x. So accordingly I will insert my values and I will get, right? If it is given at most 6 success, so it will be p of x less than equal to 6, and suppose it is given say 3 to 6 strictly, so it is given p from 3 to 6, right? So this was all for today. We will discuss next thing in next video.